Hello and welcome to today's session. We're looking at electricity and circuit calculations. So we'll just outline the problem solving strategy for circuit problems like this. So we've got a cell and it doesn't have any internal resistance. It's got an EMF of 12 volts connected in series with a 6 ohm resistor. And you've also got a 4 and 8 ohm resistor in parallel. And we need to find the current flowing through each resistor. So how are we going to tackle this problem? What we need to do is find the total circuit resistance. So we need to find the parallel combination, the effective combination of the 4 and 8 ohm resistor, add that to the 6 ohm resistor. Once we find that, then we can find the current in the circuit, because the current passing through the actual cell, because we've got the voltage, the EMF due to the cell, and we'll have a total resistance, so we can find that current. And once we've done that, we can find the potential difference across the 6 ohm resistor. We'll find the potential difference across the 6 ohm resistor because we have that current. And from that, we'll know the potential difference across the other two resistors because they're in parallel. So the difference between the PD across the 6 ohm resistor and the EMF will give us the PD across the parallel combination. From that, we can find the current through each resistor. So first of all, we'll find the parallel combination. So the parallel combination, what do we use? We use the resistor combination rule. So 1 over RT is equal to 1 over R1 plus 1 over R2. We've got 4 ohms and we've got 8 ohms. We can put them all over 8. So put that over 8, so that's going to be 2/8, isn't it? So in total we'll have 3/8. So our total, remember, we have to invert. So our total is equal to 8 over 3 for the parallel combination. And we'll put a value to 3 significant figures. So we know we're going to have a reoccurring value, but we'll put it to 3. So 2.67 ohms. So what do we need to do now? We need to find the total combination, the total resistance in the circuit. Total resistance is equal to the 6 ohm plus the combination. So we've worked out the effective combination of those parallel resistors, and we add that on to this value here. So our total resistance is 8.67 ohms. Right, now what do we need to do? We need to find the current flowing through the cell. So because we've got this resistance, we've got a load in the circuit, we're going to have a current flowing through. So the current through the cell, what equation do we use? We're going to use V equals IR, and we rearrange that to find R. Sorry, to find I. I is equal to V over R, and we've got 12 divided by our effective combination, which is 8.67. That gives us a value of current as 1.38 amps. Okay, so let's think about this. We've got this current flowing through the circuit. It's a series circuit, so we know if we draw this conventional current from here. So that means we have 1.38 amps, 1.38 amps there. But we know from Kirchhoff's first law that when we get to this junction, this current is going to split off down these two paths here, and then when it comes back out, it will have to be 1.38. So we know that by Kirchhoff's first law. Because we have a series circuit, the next thing to do would be to find the potential difference across the 6 ohm resistor. So why do we do that? If we find that, then we'll know what the potential difference is across the parallel combination, because if you remember, in series the PD adds up across components. So another rule, if you remember, the sum of the EMF is equal to the sum of the PD drops from Kirchhoff's second law. So now what we want to do is find the PD across the 6 ohm resistor. So we'll find the PD. So PD across 6 ohm resistor V is equal to IR. We know what I is, it's 1.38. So 1.38 times 6 will give us the PD. So 1.38 times 6 gives us a PD of 8.28 volts. So that means if we think about the remaining PD that's left, the PD across these two resistors in parallel is going to be equal to the difference between the EMF and this PD across the 6 ohm resistor. So PD across parallel is going to be 12 volts, because that's our EMF, minus 8.28 volts. Gives us 3.72. Okay, so we know we've got 8.28 volts across here, and because this is in parallel, we've got 3.72 volts. Now what do we need to do? We need to find the current in the 4 ohm resistor and in the 8 ohm resistor. So what we can do is, if we find the current in the 4 ohm resistor, then we can use Kirchhoff's first law to find the current in the 8 ohm resistor, because we know that this 1.38 has to split up into these two branches. So if we find one of them, we can find the other one using the first law. So that's our next bit. We're going to find the current through the 4 ohm resistor. Again, we use V equals IR, and current is equal to the voltage divided by resistance. I is equal to voltage divided by resistance, and we know it's a parallel combination and they've both got the same PD across them. So 3.72 divided by 4. That gives us a current of 0.93 amps. So the current through the 8 ohm one will be, so we calculate the current through the 4 ohm, and we can use Kirchhoff's first law. Because we've got current at a junction, so it has to be equal. So we know that it's going to split off. Using Kirchhoff's first law, we can find the current through the 8 ohm resistor. So what does that mean? We've got 1.38, if we want to write this out then, 1.38 ohms is equal to 0.93 plus, we'll call it this for the 8 ohm resistor, I8. So we can find out what the current is through that 8 ohm resistor by subtracting that. So I8 is equal to 1.38 minus 0.93. And that gives us a value of 0.45 amps. So we've done that then. We've answered all the bits in the question, and it's a typical problem that you'll have. You'll be given a circuit and you need to find the current that flows through resistors, but in order to do that we have to use our rules. So you've got a series circuit but you've got a parallel combination. Find the parallel combination, then find the total resistance, then we find the current through the cell. Once we have that total resistance, find the PD across the resistor, this resistor that's here in series, and then because we know we've got this parallel combination, the rest of the PD is across these two, so these two have the same PD. Once we've done that, then we can calculate the current through one of them, because we use I equals V over R, and then we can use Kirchhoff's first law to find the other one, because the current into the junction is equal to the current out of the junction. And that's how we tackle that particular problem. Okay, if you've got any further questions, let me know, drop me a message on Teams or send me an email. Thanks for listening.